Hi, my name is Brent. I'm a rising senior at Northern Valley Old Tappan Public High School, and this is my hovercraft, which I have named the Levkov. This is a hovercraft. A hovercraft is any vehicle that uses an air cushion that it rides upon in order to move very quickly over friction-heavy surfaces or any surface whatsoever. The hovercraft uses a lift fan, which allows it to generate the air cushion, and a thrust fan so that it can move across surfaces. The hovercraft, this one in particular, is powered by a 3-cell 11.1 volt LiPo battery. This battery gives it a long operating life and allows the two fans to have a very large source of power. The battery is connected to a switch, which acts as an emergency cutoff in the event that there's an electronic accident, or just simply I'd like to do work in the hovercraft or turn it off. The ESCs, electronic speed controllers, are wired to terminal blocks, and that allows me to make the hovercraft very modular. I can plug other things into the terminal blocks. I can do work on the ESCs if I need to. It makes it much easier for me to fix and change the hovercraft at will. The main EDF is stored in the lift fan holder, which is comprised of several sheets of Depron, a very moldable foam, and several pieces of laser cut wood, which are very hardy and allow the lift fan to be held in place very sturdily. The two ESCs control the EDFs. This is necessary because they are brushless motors that incorporate a signal in order for them to operate. So that way there's a positive, negative, and a signal wire coming out of each one. The ESCs are microcomputers in a way. They control the EDFs, and they also communicate with the receiver, which communicates with the transmitter. The transmitter has multiple control for surfaces, and that allows me to control the hovercraft multiple channels of direction. The servo for the thrust fan, which allows it to do thrust vectoring, is encased in a solid piece of PLA 3D printed plastic. This allows me to screw in the servo without any issues, and allows me to fix it if it needs to be taken out without having to hot glue it in and permanently attaching it. The brushless motors are special in terms of motors because they don't have brushes inside that normal DC motors do. That allows them to have a longer operating life, but it also means that they have to be computer controlled. They're not directly connected to the battery. The actual piece itself, the structure, is comprised of 3 layers: the top layer, the bottom layer, and the middle layer. The middle layer is only a few pieces of Depron, and that allows the air cushion to be vectored throughout this piece of the tarp, which surrounds it and acts as the skirt for the hovercraft. The bottom of the hovercraft is a singular hole. That creates a very, very large air cushion and prevents the hovercraft from sliding too much with friction. In creating my hovercraft, there were several challenges, one of which was 3D printed warping. As you can see, the thrust fan holder has warping on the side. This occurs when you have a very large flat surface being 3D printed because the plastic does not cool evenly. What this means is some planes become warped in that they lose their angular shape, and this creates a piece that sometimes does not fit the original expectations of dimensions. Another significant problem I had was parts breaking. At one point an ESC actually melted, and we really didn't have any idea why. But this also meant that I had to wait for more ESCs to come, and thus prolong the time it took to actually create the hovercraft. Another big problem was the Depron, and this is because the Depron, while being very moldable and very light, was also very prone to bending. What this meant is that the hovercraft can only be used in a low power setting in terms of the lift fan. If the lift fan is pushed past a certain point, the Depron underneath will bend, and the hovercraft will lose its cushioning, its air cushioning. It was fun to create this, and it was very interesting because I got to manage and create my own project. I haven't been really able to do that before, but now with this I've been able to learn how to create my own project. I've learned how EDFs and servos work. I've learned how to correctly make a 3D model and then print it. I've learned a lot about wiring and how that contributes to a successful project, and how some batteries are different than others, such as this LiPo, which is significantly different from things like AA batteries.